This is Cosmographia, the Randall Carlson podcast. And welcome back, ladies and gentlemen, to the Kosmographia podcast. We are all quarantined in our houses, and this podcast goes on no matter what. So we are joined once again by Brad. Bradley, how you doing, sir?
Evening. Quite well. Thanks, man.
All right. Mike, Silent Mike.
Howdy.
And Randall.
Hello, guys.
What comet is that behind you?
That is Hypothesizing.
Ah.
And we will be having some discussions about Hypothesizing in the near future.
All right.
1997.
Is that right? That's what came to mind right around there.
Yeah.
97.
It came right on the heels of Hale-Bopp.
Right. Exactly.
Now, we were talking a little bit before the show that Atlas, I can't remember the number designation, but it's coming in.
Mm-hmm.
And it's about to do a sun grazing event. They're not sure how bright it will get, but it's actually been brightening a lot faster than they expected, so it may actually get visible to the naked eye.
Visible.
Yeah.
It's going to be about 8 million miles away.
Right.
I'm not sure about the sun, but it's not going to come very close to the Earth.
Right, but if it survives the circuit around the sun, when it comes back around, it may be spectacular, is what they were saying.
Yeah.
We'll just have to see.
Shooting off some sparks.
Yeah.
Yeah, they said it might be visible in the daylight.
Yeah.
That'd be cool.
All right.
Mm-hmm.
Well, it's this one right here. Can you see its track?
Right. Randall has one comet
is.
Behind him. Brad has all of them.
That's right.
Actually, guys, those are near-Earth asteroids.
Okay.
NEOs.
Near-Earth objects, yeah.
Let's get that clear, okay? Let's get straight on that point.
Sorry. I didn't mean to get that wrong.
Hey, my job here is to get everything wrong.
That's right.
I've been doing great at that, I think.
Yeah, we have an accuracy goal. 98.6% wrong for us. Not you, but that's our job. That's our goal, right?
No, I do actually occasionally get things wrong. I've been known to. Thinking about it, I made a mistake in 1976. I got mixed up on something and got a little confused, but I quickly got it straightened out. So
I think it was
pretty good since
1977.
Oh, right. It was 1970. That was my second mistake.
Now there's two.
It was actually 1977. That's that brings up an interesting phenomena, because a lot of the critical comments that I've received or seen, and Graham has gotten a lot of these critical comments too, where it's like somebody who amasses somebody who gathers together huge masses of information and makes an effort to correlate this information into some kind of a coherent whole. Okay, and as you're going, of course, you're trying to interpret what this means. You're looking for patterns, you're looking for connections and correlations, because ultimately you're looking for causation. Well, obviously, you're going to try out things that don't work. You're going to make mistakes. You're going to put out a hypothesis to test. Okay, so what the faux critics like to do is they'll go through your whole array of stuff. They'll single out one particular error or mistake or misstatement. Then they will try to use that to discredit the whole mass of information, the whole, the whole construct. And I have seen that over and over and over again, and it really is outstandandingly dishonest.
Yeah, it's fallacy of composition, I think.
Yes. Yeah. So, what we're looking at here is we're looking at a mystery. Now, the fact is, I've probably been looking at it longer than most people. So I probably have considered more possibilities, explanations, and so on. And it's not it's not an aggrandizement of my ego. That's not what it's about. It's just a simple fact. If I started studying this stuff, say in the early to mid 70s, in seriousness, then I've accumulated quite a few years of study into this subject. So in spite of myself, I'm going to have learned something, right? And it doesn't mean I have the final answer on anything, because in fact, I think part of why we're doing this podcast is to spread the information out there, to democratize the information in a sense, so that more people will get interested in it, begin to look at it, begin to think about it, because at some point we're going to hopefully solve this mystery or mysteries of all of these varied things that we're looking at, and hopefully and presumably to the betterment of our situation on Earth. Because obviously, if we're going to have some kind of a sustainable and successful future as a civilization on this planet, we have to be looking at the big picture and seeing where what we're doing here over a period of, say, centuries, not just year to year or month to month or week to week, that we're looking at the big picture, because nothing will survive if you're only looking at the narrow range from week to week or from even year to year. So what we're in right now is a situation where science, for all of its power, has become so over specialized, and this is both its power, but it's also its limitation. And so the idea here is that we really need this cross-disciplinary pollination to take place big time. And it's obviously it's beginning to happen. But when you begin to look at some of the disciplines that would be germane to these questions that we're raising, obviously geology, right? Paleohydrology, astronomy, archaeology, right? All of this, botany, when you're talking, palinography, when you're looking at pollen studies, stratigraphy, that's studying the layers of rocks. I mean, the list goes on and on. When now you look at these papers, like some of the papers that have been authored by, 24 scientists, coming at many angles, say, to this question of the Younger Dryas Boundary, this is what we see happening. It's this cross synthesis taking place, which is so important and so valuable. But one of the limitations is that many of the participants in this process are, again, very specialized. So how does, let's say, an archaeologist then talk to a palynologist? Well, the two have obviously come together because the palynologist can go and look at the strata that the archaeologist is looking at, finding a certain example of debitage, and then the palynologist looks in there and finds, oh, there's plant pollen. So we know that these kind of plants were growing in this environment that these guys were living in, right? You can look at, a geochemist is looking at, might be looking at oxygen isotopes, might be looking at the type of chemical substances preserved in lake course sediments or in ice sheets, right? And they can infer information from that. Well, now an astronomer is not necessarily going to know about the significance of a particular, ammonium layer in an ice sheet, right? That's not within their field of specialty. Yet the two things have very much to do with each other, because changes in the astronomical environment are going to be reflected in various ways into the varied landscapes of Earth, including the cryosphere, which is the layer of ice, which is the ice world, the world of ice. So what we see happening now is this really profoundly interesting synthesis taking place. And there is a big need and room for generalists who may know enough about astronomy to get by. They may know enough about paleohydrology to get by. They may know enough about mass extinctions to get by, but obviously there's going to be specialists that know more specifically about these things than the generalist. But on the other hand, the generalist may know a lot more about astronomy, say, than the paleontologist knows about a particular species of extinct animal that lived at a certain time. You see what I'm saying? So the role of the generalist is to help to facilitate this communication between the specialty disciplines by at least not necessarily mastering a specific discipline to its maximum, right? But at least having a working knowledge of that discipline so that the paleontologist can talk to the astronomer and look for the common ground, because it's pretty much we could almost say a foregone conclusion at this point that the astronomical realm has played a huge role in the biological realm. But if you go back 30 or 40 years, 50 years, nobody was really looking at that. Nobody's looking at the correlation there. In other words, if there's an extinct animals, well, nobody's really looking at the fact that extinction may have been brought about by something that happened in the astronomical environment. So that's kind of where we fit in, where people like us and what we're trying to do, and what I'm hoping that this venue does is begin to bring together people of varied disciplines, and we can begin really a learning process. Because I'm just a student like the rest of us. I may be more like a graduate level student than a freshman level or sophomore level, but I'm still a student. I'm still learning. I'm still figuring things out. And hopefully I'm going to be around for a long time yet and have plenty of time to learn a lot more, because it's so damn interesting and I'm so damn curious about the answers to these questions. So in any case, what we've been looking at here over a number of episodes now is the Younger Dryas events. And the reason why we want to focus so intently on the Younger Dryas events is simply because those events would easily classify as the most significant events that have happened on this planet in 100 or 200,000 years, in terms of the changes to the biosphere, the rapidity with which they occurred, and the fact that human beings were around during the Younger Dryas. As profoundly important, let's say, as the events around the Cretaceous Tertiary boundary are, that's so far removed in geological time, some almost 66 million years, that only in the very long framework of evolutionary change does that have relevance to what is happening now, what happened since humans have been around and since history began, right? Whereas the Younger Dryas is right on our doorstep. It brings these powerful cosmic events and puts them right on our doorstep. And our ancestors lived through these events, whatever they were and whatever triggered them. They lived through the processes that caused the mass extinction of half the great megafaunal species of Earth. They lived through these processes that caused the inextricably rapid meltdown of the great ice sheets, right? They survived these events. The things that we're going to be have been talking about and will be talking about at least over several more episodes, simply because there is now a very substantial body of research about the Younger Dryas, the events leading up to the Younger Dryas, the events post Younger Dryas, and how that led into what we would think as the modern the modern framework of history, which I think we can legitimately push back to about 10,000 years, even though the written record is usually placed in Sumer, roughly 5,000 years ago, right? That is just sort of a phase manifesting within what we could think of as the cycle of modern history. But its roots go back 8, 9, 10,000 years ago with the building of the first cities and the dispersion of languages, and probably most importantly, the shift from dominantly hunter-gatherer lifestyles to sedentary agricultural lifestyles, which was one of the really big changes that came out of that shift, right? So we see that modern civilization, to a large extent, required an agricultural-based civilization because, for one thing, agriculture allows being in one place at one time. So you're not going to have architecture without being preceded by agriculture, right? You're not going to, as long as you have roving bands of migrant hunter-gatherers, you're not really going to have architecture, right? Architecture seems to imply a stable culture over multiple generations, right? For one thing, there's no motive. I mean, how do you hunt or gather if you're stopping to build architectural edifices? No, if you're building architectural edifices, somebody else is procuring food. And what it appears is those architectural edifices show up immediately in the wake of that transition from the hunter-gatherer to the agricultural-based civilizations. And it very well could be that agriculture was much more challenging during the Ice Age, because if carbon dioxide levels were down to as low potentially as 180 parts per million, is it even possible to cultivate most food crops at that level of CO2? I think we're looking at that there would be a great deal of carbon dioxide induced stress induced by the paucity of carbon dioxide that would make agriculture perhaps very difficult. There's some interesting studies on that we should actually look at. But yeah, this is to me what makes that Younger Dryas so important, because the whole stage that we think of as modern history goes right back up, and the backdrop of that stage is the Younger Dryas. What's on the other side? Well, see, this is thing where it's wide open. And up until recent times, the assumption is that it's a continuum. There's no break there necessarily. There's no interruption of the placid, gradualistic flow of evolutionary change, whether that was in the biosphere or whether it was in the evolution of human societies. It's a smooth curve, right? And there's no really there's some bumps in it, but there's no real break. There's no interruption. The Younger Dryas is an interruption, a major interruption. And last episode, we started looking at the evidence for the collapse of humans, the disappearance of humans in the post-Younger Dryas landscapes, right? I will predict with confidence that as we go forward with additional studies, we will discover that the drop in human population numbers was substantial and it was global. Now, when you begin to understand the geomorphic changes that accompanied the climate and environmental changes, it's at that point that you realize, well, most of what existed prior to this, and if we want to go back 25 or 26,000 years ago to the last phase of the Great Ice Age, people should think about this. Imagine the North American continent as it is now. Imagine then that there's a shift and the climate of the planet goes into a new ice age. And now you have this rapid buildup of ice sheets over 6 to 7 million square miles of North America. So you got all of the northern United States and all of Canada that within a very short period of time, I'm talking only a matter of centuries, is now buried under a layer of ice, right? Now, I don't necessarily mean that the layer of ice is a mile or two thick. That's going to take 4 or 5 or 6,000 years. But the shift that would bring about the conditions that would allow for this accumulation to begin, you're talking about, okay, let's imagine in North America that somehow the climate switch changes and we don't have spring this year. And in fact, we don't have spring, we miss summer, and we go into a permanent winter that now lasts for 10 or 15,000 years. You see, that's essentially what would happen. That's one way of looking at it. Now let's suppose, because this is what happened essentially between 25 and 30,000 years ago, with the onset of the final phase of the so-called late Wisconsin in North America, okay, which would have been the Würm glaciation in Europe that created the big Fennoscandian ice sheets, right? So you have some shift. Whether there were residual ice sheets or not is an open question. There probably were from the earlier glaciation. But for most part, over Canada at 30,000 years ago, the ice sheets were so constricted relative to what they were 10,000 years later that they would have only been basically pockets of ice, right? You had vast forests, boreal forests growing over northern Canada very much like you do now. Alder trees, spruce trees, larch trees, all of these kind of northern tree species, okay? So now let's, in our imaginations, let's think in terms of if what happened, say, between 26 and 28,000 years ago was to repeat itself. Well, within a millennium, what is going to be left of any evidence of human habitation of Canada or northern United States? Let's say where Toronto is, where Montreal is, right? Where Detroit, New York, Philadelphia, Boston, okay? Because now you've got these massive ice sheets moving across the land, destroying everything in their path, essentially, right? Grinding up. I mean, we know from looking at glacial till that, you know, the movement of these ice sheets simply just grinds up the landscape, literally pulverizes it, grinds it up, right? So now you've got the accumulation of these huge masses of ice reaching from the Atlantic Ocean to the Pacific, growing, the sea level is dropping. The margins of the ice sheets, like the big movie The Blob, is just extending outward and outward to capture that exposed shoreline that's being revealed as sea level drops, because essentially the margins of the ice sheets didn't correspond with the modern coastlines. They corresponded with the late Pleistocene coastlines. See? Now you have this huge mass of ice covering millions of square miles, pretty much pulverizing everything in its path. Now, about 15,000 years later, you start having these massive pulses of melting that occur. Literal tsunamis of meltwater are coming off the ice sheets. And I say literal because when the paleohydrologists began looking at the scale of these meltwater events, in order to talk intelligibly about the scale of these things, they used the term spheredrup, right? Which was a term developed by oceanographers to talk about these great, you know, for example, the Gulf Stream. A spheredrup is 1 million cubic meters per second. The closest we come to that on the planet today is at flood stage of the Amazon River. That's the only place you're going to even get near a spheredrup in a riverine environment, right? But we're talking spheredrups now. These meltwater floods coming off of the ice sheet are being measured in spheredrups. Millions, hundreds of millions of cubic feet per second. And if those meltwater floods are concurrent, you know, let's say if the Bonneville flood or the Missoula flood or some of the floods in the Ohio River, in the Mississippi River, in the Missouri River headwaters, the Hudson River, all of these rivers were conveying enormous amounts of meltwater, orders of magnitude beyond the modern flood stage, right? If any of those are operating simultaneously, then you're talking about billions of cubic feet per second of meltwater issuing off the ice sheets. Now, anybody knows if you've got fast-moving water, you know, moving at 20 or 30 miles an hour, and it's 3 feet deep, it's going to pick up an automobile and sweep it right along. It can wash a house off its foundations. Now, what's going to happen when you have water that's 500 or 1,000 feet deep or 1,500 feet deep and it's moving 50 or 60 or 70 miles an hour? You see, what kind of, envision any kind of civilization you want existing there 30,000 years ago. What is going to remain of that after the end of the last ice age, after it's been through that full cycle? First, the onset of the glaciers, and then the melting of the glaciers. You go through a full glacial, interglacial cycle. Whatever had been there before, how much of that's going to be left? What are you going to find to say, oh, yes, here's the infrastructure to show they were building cities 30,000 years ago? You're not much. Now, what are you going to find? Perhaps things like Göbekli Tepe, where you've got something that's dating to 11, 12, perhaps older 1,000 years ago, right? Double the age of the pyramids, when all of the conventional models basically surmise that there were dominantly hunter-gatherers. But again, the scale of Göbekli Tepe, the fact that it incorporates really interesting symbolism that maybe Martin Sweatman has figured out. I've not, others have attacked him saying, you don't know what you're talking about, but they have no idea either. I mean, they have no idea. They have no explanation for Göbekli Tepe. Well, let's suppose that we've got a situation where 12,000 years ago, you've got a society with enough organization that they can undertake a project like that. I mean, there's all kinds of implications to that.
Yeah.
Right? And it seems like the purveyors of the conventional models of prehistory are really scared to go there. They're scared to begin going down that thought process. Because why? What's it going to lead them to? Well, it's going to lead to, to what most of us who are involved in this kind of stuff already know, that the prevailing models of prehistory are collapsing before our eyes, and we're not quite sure what's going to emerge in the aftermath of that. But it's certainly, the outlines that it's taking are certainly intriguing and interesting. Yeah. And the evidence is pretty much overwhelming that there's a lot more to the story of prehistory than has been recognized on multiple fronts.
Yeah, the other interesting thing to me about Göbekli Tepe is the dating. The dates put it alongside or actually previous to what they think of as the beginnings of agriculture in that area.
Yeah.
Which is really fascinating, because you're like, okay, so they were both inventing megalithic architecture and high relief carving and right angles and all this other stuff at the same time as they were also inventing agriculture. These guys were geniuses, right? They just said, you know what, hunter-gathering sucks. Let's start doing all this other stuff instead. And they just invented all of it right there. That's very interesting.
Yes.
Yeah.
And very suspicious.
Yes, very suspicious.
Very suspicious. And it certainly does, it's just one of many threads of evidence that suggest something much deeper. And of course, I'm a big advocate of the idea that when we begin to look at the record, if we want to call it the sacred record that's been handed down through myth and legend and folklore and so on, I think that is a profoundly rich source of information and insight. And I think that, once we can get past this, I guess you want to say this modern chauvinism that is very dismissive of the past, that takes everything, well, it was all meant literally, that Phaeton literally had this chariot and was flying through the heavens. And of course, we know that that's not the case, that nobody was doing that, but when it's interpreted symbolically and realizing that mythology and even the sometimes, an example could be, tales that are told to children, fairy tales, Mother Goose rhymes even, are highly symbolical, right? How did that symbolism get there? And it's easy to dismiss. I all the time I'm seeing people dismiss, Graham Hancock is a believer. He believes in astrology.
Yeah.
Right. Like every day, Graham Hancock opens up the newspaper and reads his horoscope and thinks that that's real. Not understanding the roots of astrology, that if you want to understand the mindset of ancient cultures, you have to understand the idea behind astrology, which is simply that events in the heavens influence things on the earth. Right? Now, something going on in the heavens may not have anything to do with, who I'm going to marry or what kind of a job I get. Of course, that's taking it, reducing it down to the, to the most simple-minded level. But that is not astrology from the archaic cultures. That is not what it was about really for them. Now, of course, we can see degenerate forms of it, obviously, like everything. But if we want to understand the mindset of the ancient peoples, we have to understand that they were obsessed with what was going on in the heavens and the influence or effects that those events in the heavens had here on Earth, right? And out of that, of course, was born our observational astronomy, which has its roots, again, going back to Egypt and Sumer, and then coming through the Greeks to the Chinese. We have incredible records of cometary activity that we've inherited from the Chinese 2,000, 3,000 years ago, right? And of course, then we've also got the situation that so much of the ancient record has been lost or destroyed. Lost through the vagaries of time or deliberately destroyed because it did not support some orthodoxy that some authoritarian group was trying to impose on society. Or it contradicted their particular dogmas. The great library that was destroyed at Alexandria, perfect example of, hundreds of thousands of volumes of ancient writings and lore. Who could even begin to imagine what might have been in there? And then you've got a comparable destruction at the Library of Carthage and others, not quite so large scale. But, when we begin to look at what has been lost, what we've got now is but a pittance. But even from that, we can see that there's far, far more to this story. And so one reason why we want to understand the Younger Dryas so thoroughly is because it is the background on the stage. And we want to understand the meaning of that background, because only by understanding the meaning of that background are we going to be able to penetrate, right? Because in fact, behind that backdrop, there are the remnants, I think, of lost worlds. And the fingerprints and the footprints of those lost worlds are strewn all about the planet. And, 100 years ago, we didn't have the ability, the technology, really to begin to assemble a coherent picture out of these widely dispersed pieces around the planet. But now we can. And that's why we have to quit indulging in so much pointless bullshit that so many people are obsessed with, right? Because most of what's out there in mainstream is a gigantic distraction. And if we're going to have a future, we've got to understand our past. And this does not mean shutting down modern civilization, because if we do that, well, we're going to end up being totally vulnerable. Because one of the things we're going to be really hammering on over and over again in these series is how dynamic this planet really is that we live on. And what that dynamism means, not only for our past, but for our future. And how extreme and how frequent have been the natural changes in the environment, with the obvious implication that to dismiss those forces of nature that have been operational on any time scale that we can observe or measure, that will be our undoing. Yet, there is an entrenched faction now that is attempting to do exactly that, to remove from the social dialogue the idea that there are things that are going to occur no matter what we do. Catastrophic things that will have catastrophic effects on the biosphere, things that will have catastrophic ecological and environmental effects. And in fact, as it may turn out, ironically, the very infrastructure that we're creating, the science and the technology that we're creating may be the saving grace. It may be the very thing that can help mitigate the intensity and frequency of some of these natural events that have completely disrupted the planet over and over and over again. Far more than a mere 100 parts increase in a life essential trace gas in the atmosphere, whose thermal capture abilities are already almost completely exhausted. So let's talk about a little bit about the work of Anders E. Carlson. No relation as far as I know. If you see a reference to a Carlson in the peer-reviewed literature, it's probably Anders. It's not me. Not yet, anyway.
Not yet.
Not yet, yeah. Now, he wrote a really, really great article back in 2010 that was in the journal Geology. And, of course, this is post-2007. He has not embraced the ET impact hypothesis. At this point, I'm not sure where his thinking is now. But nonetheless, he's taking a pretty, what I consider a balanced view of the Younger Dryas events. And so in the April 2010 issue of Geology, not the Journal of Geology, but Geology, simply Geology, one of my favorite magazines to read, journals, he says this: the Younger Dryas cold event, then he has his brackets, circa 12.9 to 11.6, has long been viewed as the canonical abrupt climate event. So this is a decade ago, and he's referring back to previous decades of research. The North Atlantic region, with a weakening of the Northern Hemisphere monsoon strength, one of the effects. Right? Although it is generally accepted that the cold event resulted from a slowing Atlantic meridian overturning circulation, which is usually abbreviated capital AMOC, AMOC, Atlanta Meridian Overturning Circulation. In fact, it was in the news a couple of years ago because of the fears that the melting ice over Greenland was going to interrupt the AMOC, because there is evidence that the AMOC has been interrupted a number of times before. And one of the early theories as to the cause of the Younger Dryas was that you had the sudden discharge of large proglacial lakes, for example, Lake Agassiz, and this rush of fresh water into the North Atlantic caused this interruption within this Atlantic meridional overturning circulation that, between equator and Arctic Circle, it just keeps turning, right? So that was the idea. But at the time that idea was prevalent, it was assumed that the Younger Dryas effects were pretty much limited to the North Atlantic. Well, it's clear now that the Younger Dryas signal has been registered all over the planet. It was global, not limited to just the North Atlantic. Also, the timing of the hydrological events were eventually turned out to be inconsistent with the timing of the onset of the Younger Dryas, at least because the draining of glacial Lake Agassiz. Now, we've talked about some of the work of James Teller, where he discovered meltwater influx coming from the Lake Nipigon area into, which would have led into the Mississippi River Valley, dated at 12,900 years ago. We'll come back to that because it's critically important. And there are studies we haven't looked at yet suggesting massive meltwater pulses into the Arctic Ocean via the Mackenzie River Valley that also seem to be associated with that. However, would that have a signal that is preserved in New Zealand? See, that's part of the question. So he goes on to say, Anders Carlson goes on to say that the forcing of the AMOC reduction remains intensely debated. So there's no consensus at all about whether or not that was the trigger. Now, to me, I would say, okay, well, clearly, no doubt, a huge influx of fresh water into the North Atlantic is going to affect ocean circulation. But is that the trigger? What is the source of the meltwater? You see, you've got to go upstream further with this thing. You can't stop right there and say, oh, it's just this gigantic inrush of meltwater. Well, what was the source of the meltwater? If the meltwater was the trigger for the interruption of the overturning circulation, what was the trigger for the meltwater? Well, obviously, you had to provide thermal energy from somewhere. What was the source of that? You see, so they haven't really answered anything. As he goes on to say, the most common means of slowing AMOC involves the reduction of oceanic surface water density via an increase in freshwater discharge to the North Atlantic. Fine. But whence comes the meltwater? Okay, so now he's talking about the work of Malott, who we're going to be looking at because Malott did a comparison, a comparison of the nitrate imprint of Tunguska compared to the nitrate imprint of the Younger Dryas proposed boundary impact. Very interesting study, and we had a really actually interesting comment that I think we might have addressed in an earlier podcast. Have we posted the responses yet? Any responses yet to comments?
We posted one of them.
Okay, I'd like to review that because we may have addressed this somewhat in that particular, because it raised questions about there should be based upon the amount of nitrates found in Greenland ice as a result of the 1908 Tunguska event, there should be a really big spike of nitrates in the Greenland ice from the Younger Dryas putative impact, right? There was one study done that Malott and his co-authors were looking at. They did not find that spike. The problem is the sampling resolution was too large. The spike's going to show up within 1 to 2 years. So if you're not sampling that exact 1 or 2 years, you're going to miss the spike. So what needs to happen is go back and more detailed, precise studies of the Greenland ice sheet in there to try to find out if that nitrate spike. Now we're going to come back to the significance of the nitrate spike in a minute. So in that very same issue of geology that I'm quoting Anders Carlson from, Malott presents a quantitative assessment of the effect a comet would have on atmospheric nitrate, as well as estimates of its consequence for atmospheric ammonium, providing a test for the occurrence of a bolide at the onset of the Younger Dryas. Accordingly, comets break down nitrogen, N2, in the atmosphere to nitrate or nitrate oxides, increasing nitrate concentration. So Malott and his authors use a two-dimensional atmospheric model to simulate the nitrate and ozone changes associated with the 1908 Tunguska event, where a bolide airburst occurred over Siberia, Russia. The model performs well for the Tunguska event, accurately simulating the nitrate increase of 160 parts per billion observed in the Greenland Ice Sheet Project 2 ice core record. Scaling the predicted nitrate changes upward by 6 orders of magnitude to the suggested Younger Dryas size bolide implies a very large increase in nitrate concentration that should be recorded in Greenland ice at the start of the Younger Dryas. And I'm going to do a share screen here to show the chart that we're looking at here, one of the charts. Okay. Let me get this guy out of the way. Okay, so these are records from the Greenland ice sheet. Right up here is the nitrate concentrations. And the gray band represents the Younger Dryas, right there, that gray band. What we can see is that nitrates went way up, right? The gray bar, defines the Younger Dryas cold episode. B is the ammonium. Notice when the nitrates go up, let's see, B, where is B? Okay, I'll have to come back to B. We can't see it. Okay, here it is over here on the right. Okay, I thought I had cut it off. It was under the thumbnails. Okay, so here's your ammonium, right, which is B, which is this. So you see the ammonium in parts per billion. See how it peaks right here during the Younger Dryas?
Yep.
And the nitrate. And then you have the oxygen 18 isotopic record here. Now, what happens is when these oxygen isotopes, a very oversimplified idea, is you're looking at the ratio of heavy oxygen, oxygen 18, which is to light oxygen, oxygen 16, which fluctuates with changes in temperature. That is compared to a standard. In this case is SMOW, the standard mean ocean water, which is basically the modern ratio, right? As it fluctuates, as you'll see, as the ratio of heavy oxygen goes down, that coincides with a drop in temperature. So if you look at this gray band, you're going to see some interesting things. At just flanking, 1,690 to 1,700 to 1,710 meters in depth is the Younger Dryas. And you'll see here that the temperature has dropped way down. Then it ammonium in the ice, as well as the nitrates. Now, ammonium is a byproduct of fires. So the fact that there's a lot of ammonium, and you see there's some major, there's several really big spikes of, I'm curious, I don't have a date on this spike right here, but I'm curious is how close this spike, this spike comes to the 11,600 year, or how close some of these spikes over here or back here would come to the 14,600 year date. When we look at here, we have a variety of things. Up here, we have sea levels. And notice this would be now, right? The zero is now, and we're going back to 400,000 years ago. This wavy graph up here on the top is sea levels. So notice here, the gray band is the Younger Dryas right here over on the left side of this graph. You'll notice sea level is way down here, minus 120 meters during the Younger Dryas is what it's showing right here. And it shoots way up to modern levels, literally within about 5,000 years. But if you go back through the record, you find some interesting things. You find that at about 30,000 years ago, sea levels were even higher than modern. We can go back, and here's another band showing periods similar in a way to the Younger Dryas. Notice this, the rising and falling of sea level. Where in here do you see stable sea levels? Nowhere, basically.
So that's showing that the ice sheet is melting suddenly, cyclically.
Yes, that's what it
Sudden
sure does look like. Yeah.
Refilling the oceans really fast.
Refilling the oceans really fast, growing really fast.
Yeah, so the accumulation of ice is slow and gradual in comparison to every one of those. Those are spikes. That's really strange because, I mean, one of the ideas is that the ice starts to melt, but somehow it's held in by its own, like the border of the ice is holding in this massive lake of the melted ice.
Well,
And then that breaks and then it lets it all go because of how, you throw a block of ice outside in the middle of the summer and it's not going to get a pool of water in the middle of it and then shatter and spill all over the place at once.
No, it isn't. No.
So that's really strange.
And even you can see there's 6 cycles inside of each one of those ramps too. There's 2 or 3 peaks.
Yep.
Yeah. I mean, it's a little bit disturbed, but you can see that there's a sort of a regular thing happening there. It's very interesting.
Oh yeah. Well, I mean, you can see how dynamic sea levels actually have been.
Right.
They're not, this is not smooth. This is a constantly changing sea level here. And sometimes those changes are very fast and very extreme.
What's the reason for the disruption in the graph right here near the present? All those little squares and the break in the line there. What does that mean? Something wrong with the data there?
He's giving the reference back Clark and others in 2009. So we would have to go to their paper.
Oh, okay. All right.
And I'm guessing these are, going to be a variety of, each one of those squares is going to represent a sample taken from somewhere.
Okay.
And so what this is showing is notice the horizontal distance is going to be age, you see.
Right.
So this is, if we go down here, yeah. So the dark gray bar here is precisely the Younger Dryas. You see that? See, there's a dark gray line in there. And over here, there's another dark gray line showing that right around a little shy of 250,000 years ago, there was another Younger Dryas type event.
Wow.
And see, each of these gray bar represents basically a transition from, well, when the sea level is down here, that's a glacial age. This is an interglacial age. And these gray bar represents those transitions from the full glacial to the interglacial. And they happen fast. And again, you'll notice the other disturbing thing about this is when you look at the duration of the interglacials, they're very short.
Yeah, it's not very long.
No.
Yeah. So you could imagine that right after each one of those gray bars was a civilization similar to our own right now. I mean, it could be.
Yeah, I mean,
it would be totally gone.
At this point, we've got to say that all bets are off. I mean, yeah, we've got to acknowledge that, yeah, at this point, we're free to do some outrageous theorizing. Of course, anything that we theorize or hypothesize, I should say, ultimately needs to be testable some kind of a way. How you would go about testing this, I don't know, because, I mean, think about this. Think about the destruction of one ice age. Well, what happens if we go back 250,000 years and we've had multiple episodes?
Yeah.
I mean, where's the landscape from 200,000 years ago that's intact enough that there might be remnants of some kind of human habitation?
Yeah.
Right?
Outrageous hypotheses are definitely my job.
That's yes. Thank you, Kyle. I'm glad there's somebody here that
wild speculation.
And in this graph over here, okay, go ahead, Brad, and get your 2 cents.
Well, it's just looking like, we're at the peak of the high as the sea level goes. There's one there previously. It's a little bit higher, but you've consistently got a swing there of 400 feet in the sea level going up and down, and we're about at the peak. So
yeah,
all I can do is go down from here.
Yeah, it's another sign that we're really closer to going back into an ice age where that water is going to freeze up.
And I don't know how with resolution you can see this, but if you look in this upper corner, at 0, right? 0 is the modern level. Right. But you actually see that this is going above the modern level and then coming back down.
Right.
Since the end of the last ice age. This would undoubtedly be the early Holocene thermal maximum, also called the hypsothermal.
Right.
When climate was warmer than now. And in fact, that was the bridge between the end of the ice age and the rise of modern civilization in the Middle East. 5,000 years ago. 5,000 to 10,000 years ago was with some variability, of course, but that was the climatic optimum.
Right. And that little notch where it's up above where it is like 20, 25 feet ish, right? That's what I've read that, that during the climatic optimum, it was the sea levels were between 20 and 30 feet higher than they are now ish, something like that.
Well, yeah, each little
see
band here is 20 meters.
Right.
All right.
So about 64 feet.
Let's put a little human perspective in this. The entirety of human history has taken place since this first dark gray band on the left all the way to the zero.
Yes.
Okay.
You're looking at the scale at the bottom.
Right.
Another example of the curtain on the back of the stage.
Right.
Yeah.
Now, what is the oldest evidence for modern hominins?
Oh, I think now it goes back. It's over 200,000 years.
So let's say,
it puts us back in here.
Let's say it goes back to that first gray bar over on the right, the first dark gray bar.
This one that I'm scrolling over right now.
No, further, the dark gray bar.
Yeah.
The 240.
Oh, this dark gray bar. Yeah. So that's going to be just around 240,000 years ago.
So you look at all the aside from the massive the light gray bars indicating massive change, you've got these fluctuations that humans have endured. Where's the evidence for human occupation in these eras? You know, we don't have much at all, really. It's sort of spotty.
Scattered skeletal remains is what we have.
Right.
That's where he started out, though. It's been pulverized and washed away multiple times.
That's kind of my question.
there are a few caves, basically, where
like there's the Denisovan cave in China, right?
Yeah, is that Siberia?
Siberia?
Yeah,
is it Russia or is it China? That's Russia.
Yeah.
Okay. Yeah. Well, I really don't know where I'm going with this question, except I just wanted to, like I said, get some perspective on this. That the entirety of modern human history is this small area on the left. The known human history, modern hominins, has been since the middle of the graph.
Yeah.
During which we were supposedly primitive and basically wander around a little more than hairless apes, if you like the Edmund Morris analogy. So where's the evidence? Has it been pulverized? Has it been covered by we look at the continental shelf? Even in antiquity, humans probably lived largely, as they do now, along the coastlines.
Yeah.
So is much of that buried along the coastlines?
Oh, I've said for years now, I think that really the future archaeology is going to be a lot of submarine archaeology, and that we're going to be finding more and more evidence of human occupation in those drowned coastal shelves that were exposed during low sea levels. Absolutely. But as far as what we find when we get back there, 200,000 years ago and beyond, is just modern, human skeleton, a skull that might be modern. Say, okay, well, there was this guy was here, 200,000 years ago, and he appears he was modern. A modern guy was here, right? But we don't see any evidence of any kind of civilization or anything from 200,000 years ago.
Well,
but what you're getting at, Mike, is precisely my point, is that how dynamic the changes have been, that if there was a culture capable of building an infrastructure 100,000 years ago, what are we going to look for?
Well, yeah, that is kind of my point. That was the second part of my question or my observation, that if you don't have skeletal remains, what other artifacts are there? There don't seem to be many except primitive tools.
Right.
And it's fine to hypothesize about if there were modern humans 250,000 years ago with the same mental capacity and same physical capacity, could they have built societies or cultures analogous to ours? We don't know, but there's no evidence for, there's no artifactual evidence for that at this point.
Correct.
No,
And that is why
artifactual
something like
evidence.
Göbekli Tepe is so damn important.
Right.
Yeah.
And that's only what, 15,000 years ago. That's
If that, we don't know
Yeah,
yet. I mean, but it could easily be that old
yeah,
because the most of it has not been excavated yet. So,
Yeah. I mean, there are always, stories, like there's plenty of stories of people finding interesting objects embedded in coal, like gold and chains.
yeah,
and
the
stuff.
Uparts theories.
Yeah. So there's no accepted artifacts that are advanced, that are ancient, but who knows what there could be.
right.
Yeah, and if they
But-
made a bunch of stuff out of wood, it's gone. If
Yeah.
they made a bunch of stuff out of concrete, it would be gone.
Yep.
If they smelted metals,
It's gone.
they're gone. The only thing that we would find of some civilization 250,000 years ago probably would be, stone.
Yeah, and gold if nobody had messed with it. So
But occasionally, amazingly, there are skeletons that are preserved. So
In a very fragmentary form, though.
yeah.
And, we don't really know what, human populations might have been 50,000 years ago. I mean, we can make assumptions, obviously.
Right.
Those assumptions are, that it was minuscule compared to modern. And I would be inclined to believe that myself when you start looking at a graph like this.
yeah.
I mean, what I think we're looking at is maybe a 200,000 year struggle to survive.
Yeah, but it might be like those gray bars just after that. The population spread and
Mhm.
everybody went around and started developing agriculture and some architecture and then eventually get wiped out.
Yeah. By the
Well,
next great bar.
let's look at this in the light of Graham Hancock's books, positing that you've got antecedent human cultures that are spreading technology around the world. I mean, that's the thesis of his latest book, right?
Mm-hmm.
To have some kind of higher technology, you generally have to have a population large enough to sustain that kind of intellectual curiosity and that kind of industry, that kind of growth. Whereas the evidence, again, because there's such a paucity of human skeletal remains, we don't know the population sizes back then.
Exactly.
We don't know the population sizes 15,000 years ago. How big were the supposed hunter-gatherer societies at Göbekli Tepe or across the Middle East? How big were human cultures? We so far all we know, or all we think we know, is that these were roving bands for the last 250,000 years, roving bands of hunter-gatherers. But what else do we know beyond that? Is it?
We don't know anything beyond that.
So
Yeah.
The simple answer, Mike, is that we don't know what we don't know.
Yeah. That's right.
We don't know the known, the unknowns.
Don't go Donald Rumsfeld on me.
Exactly.
I'm just. Is it realistic to posit that these things, to propose that these ancient cultures might have existed? It's nice to theorize about, but
realistically, how do we go about proving? That's
where's my crystal spaceship buried in the muck of Antarctica?
Well, okay, I don't think we're going to find crystal spaceships, Mike, but who knows what if we did find something? I mean, because within the last 200,000 years, there have been periods where Antarctica has shrunk. Problem is, when it grows back again, if somebody had built something, in the deglaciated zones, once it advances and expands again, well, that's it for whatever might have existed in those deglaciated areas around the perimeter.
But here's the other thing. If you decide that there's no evidence for it, so why speculate? Who's going to go looking for it? If everyone decides, well, it didn't happen. And that's what happened with Clovis first.
Yes.
They dig down to Clovis level, and then once they got the Clovis artifacts, they stopped digging because they knew that those were the first people.
Yeah.
Only later, when they dug below that, did they find out that there were artifacts underneath the Clovis.
Yeah.
Right.
So
Exactly.
You have to keep the option open.
you have to have the impetus to look for it.
Yeah.
So that's, I mean, I think that's important. Whether or not we can prove it, we should still look.
Yeah.
I agree.
I can't disagree with any of that. I just, I'm just wondering.
It's
Well,
a good
this-
question.
Yep.
Let's go dig in Antarctica and we'll
Yeah.
find your crystal spaceship.
We'll go with you, Mike.
Well, in our
coring
first 6 or 8 episodes, when we're looking at the whole Atlantis phenomena, this brings us back to the idea of submarine archaeology. And I tried to show that that Plato's account had a lot of consistency to it relative to what we know about the ocean floor, what we know about marine geology, what we know about late glacial geography, and so on, right? Well, there's an outrageous hypothesis that might actually be testable.
Yeah.
But of course, that's going to require enormously, well, maybe not that enormously expensive. I don't know. I mean, after all, James Cameron went down and filmed the Titanic sitting on the ocean floor to make his movie, right? So
All
who's
right,
to say?
all you Patreons, kick in for this expedition to Antarctica.
Yeah.
Find my crystal spaceship.
The Crystal Spaceship Expedition begins.
First, let's make t-shirts.
Mike Wozlevic's Crystal
Starter.
Spaceship Expedition.
Oh man, we gotta have T-shirts for that.
You get
We
some
can do a
supporters.
whole GoFundMe drive, raise millions of dollars.
Well, come on, Mike, you're the handler, so get busy. Use some of those high-level elitist inner circle connections you've got. Get us the resources.
Yeah, there we go.
In spite of my claustrophobia, I would probably be willing to go down in a submersible, I think.
Oh yeah.
With
would
Mike.
have-
Not me, dude. I'll let you go.
I'll do the squirrel so you can do the submarine.
Wait, you'll do the what?
The squirrel suit off the Grand Canyon into the raft. Remember that?
No, I don't.
Oh well, yeah.
Okay.
That's us. We're going to GoPro squirrel suit jump off the edge of the Grand Canyon down into a raft and white water raft.
Into the
And
all the
raft.
way
will you
down.
be able to film the stratigraphy as you're going down?
That's the point. Yeah, exactly
Yeah.
why we're gonna do it. Yeah.
3D
Okay.
GoPros. But yeah, you get to do the submarine.
Yeah.
Then we can do an exclusive podcast.
That's right.
Slow
And
motion.
the podcast will be entitled In Memoriam to the Serpent Brothers.
And Brad. Well,
So my
Randall, I
squirrel
think that
suit's
was
not going to work.
yeah. I think that was an excellent show, Randall. But we're about ready to wrap it up, I think, though.
Oh, okay. Well, we've got a lot more.
We do, but we
Always.
have an infinite number of episodes ahead of us. To
Yeah,
do it in.
and the deeper we get into it, the more interesting it gets.
Excellent.
And people, don't be afraid of a little bit of reiteration and so on, because remember, the devil's in the details. And so it's important really to get the detailed picture in our minds if we're going to make any kind of coherent understanding of these events. Too many people are willing, they just want to rush through things. And, you go and you look at a body of evidence, and a few months later, you've got some more evidence that builds upon the earlier stuff. But if you're now oblivious, you've just blanked out, you've forgotten this earlier stuff, you aren't going to make those connections. See,
Right.
this is one of the things I learned about, when I went through the craft system, is the iteration and reiteration over and over again. And when you think you've exhausted all insight into the meaning of a particular body of information or symbolism, all of a sudden one day, boom, you have an epiphany and you realize a whole nother, it's like you have all of these pieces and you think you see the pattern, but then one day, I always have used the analogy when I was a kid. I used to love, you probably did these too, the connect the dots by numbers.
Yep.
You did that,
Sure.
didn't you, Mike? Yeah, we all did that. And you start out, you got this page with a bunch of dots on it. and you don't really see what the figure is. But what's happening? Well, the analogy is, of course, you go from 1 to 2 to 3, and then as you're going along, all of a sudden you go, "Oh, I see it! It's a giraffe."
Yeah.
Right. The problem is we're looking at this array of dots, but we don't really have the numbers on them yet. So what we're doing is we're trying to connect the dots in various ways until we get some kind of a coherent image. Then we can go, "Oh, boom. Insight, breakthrough, epiphany. I see it."
That's cool.
You see? So each episode, we're laying out more bits and pieces of this evidence here. And of course, even as we're doing this, new discoveries are being made. So I think that this is that opening up this to a broader audience is going to be really valuable, right? Because most people are going to get their information secondhand, thirdhand, some media report, where, and it might be very dismissive. It might be very shallow. Like this is, for example, so we'll conclude with this. Give me one more minute, sir.
All right.
Anders, for example, goes on to say that he says several other issues still remain with the bolide forcing hypothesis for the Younger Dryas. For instance, the original Firestone et al. 2007 impact marker records have not proven reproducible in a subsequent study. Now, who do you suppose he's referencing there as far as the subsequent study?
Suravel.
Exactly. Similarly, a compilation of charcoal records do not indicate large-scale burning of ice-free North America at the onset of the Younger Dryas. I beg to differ with that. And in fact, I've read through the quoted article there, which appeared in 2009, at least 4 or 5 times. I can't find anywhere in there where it actually disproves. And in fact, what it does is it amasses a bunch of circumstantial evidence that, yes, there were huge fires that occurred. In their dating, they don't precisely align up, but there are actually legitimate reasons for that. And the Comet research team has addressed that, right? But, and then another recent study showed that late Pleistocene megafaunal extinctions potentially attributable to a Younger Dryas impact significantly preceded the Younger Dryas. And one of the things I've been kind of hinting at is that it appears that the first catastrophic pulse of this shift out occurred around 14,600 years ago, right? I brought this date up multiple times and talked about the 3,000-year shift out of the Ice Age from 14.6 to 11.6. 12.9 is pretty much right in the middle. But if that's the case, then yeah, it's likely that we should find that there were species loss that would have coincided with earlier episodes. And we can, just by looking at these graphs, similar to what we were just looking at, we jumped ahead and we didn't really look at the bottom graph, which was the oxygen isotope changes, which is a proxy for temperature changes. But clearly, the global climate and environment is going crazy by 14,600. So yeah, we should expect to see that there's going to be megafaunal loss. The problem is that in these studies like this, the assumption is kind of straw man. It's a simplified version. Okay, well, if there was one impact at 12,900, then if there's a species loss 1,000 or 1,500 years earlier, then that disproves an impact at 12,900. That is kind of the thinking that we've got here. So he says, ultimately, the bolide forcing hypothesis predicts that the Younger Dryas is a unique deglacial event, as suggested by the late Wallace Brecker in 2006. However, high-resolution proxy records sensitive to AMOC, Atlantic Meridian Overturning Circulation Strength, document a Younger Dryas-like event during termination 3. Termination 3 was the third to last deglaciation, and that's what we just looked at on that chart, right? I pointed back, we went back 3 glacial terminations ago, and there was that line that and I said, look, there was like another Younger Dryas. He goes on to say, Anders Carlson goes on to say, while not as well constrained, both events occurred at approximately the same sea level. Well, in other words, both events occurred when sea level was way down, meaning ice sheets were at their maximum extent, suggesting there may be a common forcing related to the size of the Laurentide ice sheet. Or, alternatively, a bolide could have forced the termination 3 event as well.
Right.
Yeah.
And that would make them a lot more frequent than seems to be comfortable for many scientists.
Yeah.
But that would be, looking at, going back to that chart you were talking about, that would be some weird periodicity to have both ice sheets and a bolide hitting like 200 and something thousand years apart.
Unless all of that's connected by big astronomical cycles. Yeah.
One thing we know is that orbits have periodicity.
Yeah, everything's going around something else.
Yeah,
but
and
periodicity with the with massive ice sheets too. That's really weird.
Yeah,
it is weird, isn't it? But if there is an astronomical explanation, which I think is clearly indicated at this point, then that's what we need to be looking at. I mean, when we look at the astronomical world, I mean, what is the prime characteristic of pretty much everything that we see in the astronomical realm is cyclicity.
Yeah.
Everything's going around something, right?
Really fast too.
And I don't think we should, rule out a priori the possibility that there is a periodical influx of cosmic material into the inner solar system that can have profound effects on the state of the global environment.
Yep.
It would be interesting to see Milankovitch cycles overlaid on that graph too.
Yeah.
Well, actually, they're on that graph. The very bottom curve was the Milankovitch.
We'll have to go back to that on the next episode.
I'm going to have to rewind and look at that again.
Yeah, do. The problem with Milankovitch, though, is that the Milankovitch cycles are clearly affecting global climate, no doubt. And they're affecting the amount of solar insolation to roughly 1,350 some watts per square meter impinging upon the atmosphere, right? But they're so slow.
Yeah.
You see, over thousands and thousands of years that they change, right? Well, I think we have to look at long-term slow changes, but juxtaposed upon that is something else that's driving this that we're seeing in those charts and graphs.
I agree with that.
All right. Well, I think that's a wrap for this episode.
I think so. Excellent show.
That was awesome.
Yeah. So everybody can get a hold of us at Cosmographia1618@gmail.com. And also all the links for the podcast, the website, the support, join the Patreon and support us. All the links for this are down in the show notes or in the show notes if you're listening to the podcast. So join the Patreon or get on the website and click on the PayPal link and help us get an expedition to get Mike a spaceship.
Spaceship. But you could go ahead, Mike, and get a head start on your suit.
There you go.
I want one of those silver lame jobs from the early Star Trek episodes.
There you go.
Well, I think that would be appropriate. We all have our silver lame suits on for future podcasts.
Yeah, with the giant bowl helmets and the silvered front. And just nobody will be able to tell who we are.
Goes right with the tinfoil.
There we go. I'll cover mine in tinfoil. All right, gentlemen, that was an excellent show. Look forward to it next week.
Yeah, brilliant lead in.
Yes, it was a great lead in. It was very inspiring with the comet behind you.
Yeah.
I do like the graphic, Randall. That's really a great graphic for you.
It is.
It is. But it's also symbolic of what we don't want as far as the information to just
go in one ear and out the
You
other.
want it to go in and stay in there.
Just passing
That's
by.
right.
That's right.
That's right. And Hyukatake will come up in future discussions for several reasons.
Excellent.
But the primary reason is what we learned about cometary composition from studies of Hyukatake.
All right.
Awesome.
Sounds
I'll just
excellent.
mention again, we're still hoping to make a trip out to the Scablands in September,
Yep.
right? So check the show notes or the video description for the links
That's right.
there, and check out the contact at the cabin that we're planning for September and possibly into early October if we get to run another group, depending on how many people are interested. So that's something we're still pulling together, and really hoping that things are going to be back in order and functioning, and be able to have some fun out in the Channel Scablands.
That's right.
Yeah.
So
If
sign
you
up for
ever
that.
have questions, first read the show notes.
Yeah. That's
Exactly.
right.
Brad puts a lot of work into
There's
the
a
show notes.
lot of work in the show notes and lots of links. So
Yep, look for the links
always
there.
check the show notes. All right.
Excellent.
Yep. Good night,
Thanks,
guys.
everybody.
Thank
Thanks,
you.
guys.
Good night.
Good.
Until next week.
Aloha.
Perfect.
That was freaking awesome.
Yeah.